Hello friends, welcome to the new lecture series in Advanced Engineering Mathematics. So friends, here we'll be starting with the probability theory and sampling distribution. So to know more about what is this probability theory and the concept of sampling distribution, please subscribe to this YouTube channel if you have not yet subscribed. Click the bell icon for the latest notification of the videos on this YouTube channel. Also follow us on Twitter, Instagram and like our Facebook page, Mechanical Engineering Tutorials. The links are in the description below. So friends, let's begin with the lecture. So what is probability? So here, if the outcome of a trial consists of n exhaustive events, say now this is the event E and it has the possible outcomes, or you can say the possible events n, and out of these n possible events, if there are m events which are favorable, that is they are the one that can happen, we call them as the favorable events, then the probability of happening of the event E is denoted by small p, which is nothing but equal to the ratio of the favorable events to the possible events. That is, probability P will be equal to m by n. So this is also denoted as capital P of E. So this means that probability of happening of the event E is denoted as PE. So we can say PE will be equal to m by n. Now, when we know that m is the happening events, or you can say favorable cases, there will be non-favorable events also. So those non-favorable events are denoted as n minus m. So there can be also probability of the non-favorable events. So this is denoted as small q. So this will be equal to nothing but n minus m upon n. So again here it is ratio of non-favorable events to the possible events. So we can say n minus m upon n. So n minus m, I can write it as 1 minus m by n, because n by n is 1 minus m by n will remain as it is. So this can be written as 1 minus m by n. Now, what is m by n? It is nothing but probability of favorable events which we had seen just now. So that is denoted as small p, or I can write this as 1 minus p of capital E. Like how we denoted small p as capital P of E, Q is denoted as capital P of E bar. This is probability of happening of non-favorable events of the exhaustive event E. Now when I add this P and Q, I will get it as 1. So here what we can say is that the probability can at most be equal to 1, because the number of favorable cases and the number of possible cases can at most coincide with each other. So this is about the probability. So here we'll take up an example to understand. So let us consider the event of tossing a coin. So the possible outcomes are either heads or tails. That is, when you toss a coin, you will either get heads or tails. So what we can say, the events, that is n, will be equal to 2. So this is the outcome of the event of tossing the coin. So here n will be equal to 2. So if favorable outcome is heads, then non-favorable outcome will be the opposite of heads, that is tails. So we can say favorable outcome m will be equal to h, and non-favorable outcome, that is n minus m, will be equal to t, that is tails. So probability of getting heads, that is probability of the favorable outcome will be m by n, that is 1 upon 2, because getting heads is only once, that is when you toss the coin you will either get heads or tails. So at a time you will get only one head when you toss one single coin. So m will be equal to 1 and the total outcomes are 2, that is you will get heads or tails. So n will be equal to 2. So 1 by 2, so 0.5 is the probability of getting heads. Now let us see what is the probability of getting tails. That is the probability of the non-favorable outcome. So Q will be equal to n minus m upon n. So n minus m is nothing but it is the getting tails. So n is how much? 2 and m is 1. So again this becomes 1 by 2, so 0.5. So with this we can say the probability of not getting heads or the probability of getting tails is also 0.5. Now if you see here, when we add this P and Q, it will be 1. So the probability will not be more than 1. So I hope you have understood the concept of probability with this example. Now we shall move on to the sampling distribution. So before we move on to the sampling distribution, first let us try to understand what is a sample. So you take a population. So this population can be anything, a large group. So from this population, you take a part of it, we call it as sample. So a small section selected from a population is called a sample. So few examples you can see here on the screen. So when I take the taluka as the population of village will be a sample from the population of taluka. So if I take the population of the village, then the population of males in that village will be a sample. Now if I take the total strength of the class, the number of girls in the class will be a sample. So likewise, if you are taking a small selection from a larger group, we call it as a sample. And the process of drawing sample is called as sampling. So this is about sample and sampling. So then we come across the random sampling. So here it is essential that a sample must be random selection so that each number of the population has the same chance of being included in the sample. Say for example, now you have a population. So in this case, the population is number 1 to 9. Now from this randomly, I will pick number 5. So without any links or any other concepts over here, I randomly picked one of the sample. So this is called as random sample. Now similarly, I'll pick another number. Now I have picked 1. So again, this is a random sampling. Now I'll pick 8. So if you see here, there is no any link between the samples which I have picked. So they are collected at random. So these are called as random sampling. So here, one thing we can note, the sampling aims at gathering maximum information about the population with minimum efforts, also cost and time. So this is about the random sampling. So now once you know what is sample, what is sampling, we shall see what is sampling distribution. So here consider all possible samples of size n which can be drawn from a given population at random. For each sample, the mean can be calculated, and these means, which are usually not identical, can be grouped according to their frequencies. The frequency distribution so formed is known as the sampling distribution of the mean. Similarly, we can obtain the sampling distribution of the standard deviation likewise. So here we can say the sampling distribution of large samples is known as a normal distribution. So here on the screen you can see is a population. So from this population the samples are picked. Then the means are calculated. Say for example here there are 3 green samples, so a mean of green is picked. There are 2 purple samples, so a mean of purple is picked. Then there are 2 brown samples, a mean of brown. Similarly a red, then blue, black. All these will be the sample and they will be distributed here, and this is called as the sampling distribution. Now we shall see the sampling distribution of the means. So consider all possible samples of size n and mean of each one of these samples is determined. The sampling distribution of the simple means associated with a finite population are of 2 possible types. One is with replacement and second one is without replacement. So now we shall see how the random sampling is done with replacement and without replacement. So firstly, with replacement. The random sampling with replacement, here the items are drawn one by one and are put back to the population before the next draw. If n is the size of the finite population and small n is the size of the sample, then we have n raised to n samples. So now here if you see from this population, say I'm having 4 red balls and 4 black balls. So first a red ball is picked randomly from these total 8 balls. Now when the second picking is done, this red ball is put back into the population or into the group, and then another sample is picked and this time randomly a black ball is picked. So in this case we can say there will be n raised to n samples. Now the mean of frequency distribution of the sample means, that is mu x bar, will be equal to the population mean mu. The variance of the frequency distribution of the sample means will be sigma square x bar will be equal to sigma square by n, where the sigma square is the variance of the population. Therefore mu x bar will be equal to mu and sigma x bar square will be equal to sigma square by n. So this is with replacement. Now we shall see without replacement. Here the items are drawn one by one and are not put back to the population before the next draw. So here if you see there is a population again of 8 balls, 4 red and 4 black. Firstly a red ball is drawn randomly. Now the red ball is kept outside the population. Now there will be 7 balls in the total population. So from these 7 balls, that is there are 3 red and 4 black, a random sample is drawn. So this is without replacement. So in this case there will be random sample of NCN samples. So thus in accordance with notations used in case 1, mu x bar will be equal to mu and sigma square x bar will be equal to n minus n upon n minus 1 sigma square by n. So here it is small n, that is the sample, and capital N denotes the population. N minus n upon n minus 1 is the constant here, which is denoted as C. So this is called as the finite population correction factor. So this will be C into sigma square by n. So friends, that's all we have in this lecture today. So if you have understood this explanation, please subscribe to this YouTube channel. Please share this video with your friends and follow us on Twitter, Instagram and Facebook. The links are in the description below. Thank you very much.